Oh, hey, didn't see you there. I'm just working on this painting of Gregor Mendel, who was like an Austrian monk or something. I don't know. I don't really like to research things before I talk about them. So today's lesson is on gene deletion. And what is gene deletion? Well, that's a good question. I'm glad I asked. So let's go somewhere to talk about this where it's more suitable to put things in order. That was foreshadowing. Let's roll.
So let's be completely real here. There's really no easy way around it. It's hard to wrap your head around. Luckily for you, I'm here to help.
The first thing I want to talk about is pseudodominance. Normally, two recessive alleles need to be inherited from each parent. Well, one from each parent, technically, for the recessive trait to be expressed. But recessive in this case merely means that the trait is only expressed in the absence of dominant alleles, which is where this big f***ing mess of plus and minuses comes into play and how you can ultimately put everything in order. So we're going to look at number 4 on whatever problem set that was to base this off of. So the way I actually approach these is probably completely frowned upon and unconventional, but for some reason it gives me the correct answers every time, so that's what we're going to do. If you look at gene 1, you'll see that you have a deletion under deletion 1. I don't know what those are called. We're going to go by 1, 2, 3, 4, 5. So you've got a black bar across 1. Let's scan across our chart that shows the plus and minuses. Basically what I do is look for a location in which you have, so for example, with gene 1, you see empty spots with 2, 3, 4, and 5, which in this case would indicate pluses. And then you would have a black bar across deletion 1, which would indicate a minus. So basically, what has a minus and then plus, 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 plus? Scroll across, that is B, put B for number 1. Boom. Number 2, we've got 3 black bars. So 3 minuses, 4 and 5 are blank, those are pluses. Let's scroll across. A matches that up. See where I'm going with this? Yeah, so we got B, A so far. Bah. Gene C, we've got black bars 1 through 4 all the way down. You have a blank spot in 5. Let's scroll across. That looks like C. Doesn't it look like C? Let's put C there, so now we got back. Gene 4, we have kind of rotates, trying to mix this up a little bit. This isn't number 4, by the way. I couldn't find that problem set. This is just warm up or something. So we have 2 blank spots in deletion 1 and 2. 3, 4, and 5 have blanks. Let's scroll across. What's that look like? E for elephant. Gene 5. We've got 1, 2, 3 are blank. 4 and 5. Look, they've got some black bars across. Again, the black bars mean deletions. I'm going to look across my chart here, see what matches up. That looks like D, so let's put D there. Gene 6, we've got blanks on 1 through 4. And then we've got a black bar on 5, which obviously leads us with F. Let's fill it in, put them in order. Back end is our answer here. It's the order of the genes. And that's how you do gene deletion, by just kind of eyeballing your chart. Just make sure you know the terminology behind it and why things work the way they do, like I said at the beginning. And you should be good to go. But I want to end on one final quote, and that is that science is organized knowledge, but genetics is organized life. With that said, keep putting your genes in order, keep looking at your pluses and minuses, make power moves, do some big out there. You guys have a great day.